Hi everyone, my name is Ben, and here before you I have a 5.9 Cummins, a Common Rail 2006. The reason why I'm making this video is to feature a few things that would help to avoid being in my position right now, having this whole block stripped apart due to common failure on these common rails, especially the 04.5 and up to 2007. I'll explain a few things that could add longevity to these engines and avoid the problem that I got into. This video is just a compiled of all the research that I've done online and some improvements that you can do to your truck to avoid this very situation. I'll show you on this first video some upgrades you can do that without taking the whole block apart, that simple improvements that you can do to avoid this. Let me explain why we're in this situation. Just to, as you see in this picture on my iPad here, here's cylinder 1 piston ring. This is cylinder 5 ring and the cylinder 6. As you see, 5, it's broken. This is in perfect condition, but 5 broken, and again 6 broken, but even worse. You see, small chunk was missing, and because of that, we have, this is what happened. This is piston 6, and you see there's a scoring on the cylinder wall. The chunk of the ring just pitted the crap out of the piston. I wish I had the real piston here to show you, but there you go. This is what happened. Scored the crap out of the piston, the cylinder wall. And I thought the engine was shot, the block was shot, because I thought these are solid blocks. But to my surprise, and even on the Cummins manual, they say you can put sleeves if you can't bore it to a maximum of 40 thousandths of an inch. So this groove was more than a 40 thousandths of an inch, so couldn't get bored, but they could get grooved and put a sleeve in. And I'll just show you what I mean. So here's cylinder 5. See, no groove. You don't see any groove. Well, if you go to cylinder 6, you see a bit of a ring. And if I go from under, see again, you see that large ring. That's that sleeve they pressed in. And see, 5, there's a bit of a ring, but it's nothing. It's more obvious when if I took a picture. But anyways, that's what they did for me, this machine shop. So it seemed to do a really good job. And also because 5 was scored up a little bit, it was scored a little bit, so they had to bore it to 20 thousandths of an inch. So I got slightly bigger pistons going in this block. So anyways, so now the question is, why does this common issue happen with the rings to break like that? And especially 5 and 6. It's always seems to be 5 and 6 on these common rails to break. Well, the only thing that I could really find is that rings tend to break because of heat. There was just way too much heat towards the back of the block. So here are a few improvements that will help. It's funny to say that commonly it's the 04.5 and to 07. Well, it's kind of a flawed design with, well, not so much it's a flawed design, it's just the unfortunate thing about the pistons on these 04.5s and up. And I'll explain a little bit why it seems to be a situation. Here's a piston. As you can see here, You see how much meat there is here to the ring there? There's not a, there's quite a bit. Better. This is actually Molly pistons, and they're slightly beefier than the stock one a little bit, but not by much. But the problem is this bowl is big, right? And so the combustion is happening all in here, and that's really close to here, because if you look at the 03, 04, which don't commonly have this ring issue, the bowl is much smaller, and also along with the other 5.9s, the older versions, they have a smaller cup, and so for the heat to dissipate, if it had that much more meat, well, there's less heat being affected on the ring, and also less pressure from the combustion, because there's more room for it to pass by. Well, but anyways, the heat transfer here is much more, and that's the theory behind why of a common failure on these rings. And anyways, I'll explain on next video what you can do to maybe avoid the 04.5 pistons and up. And 6.7s is Cummins. I guess they don't have they went back to the normal size pistons, like the 03, 04, like not the same pistons, but the same diameter of piston or firing bowl in the piston. They went back to the smaller one, which is better and avoids rings. But and this is all because Cummins decided to do this is for emission reasons, and I don't know why. And so it's all to control combustion and make it more environmentally friendly. So anyways, this is that's kind of the reason why these 04.5 tend to fail, all because of the piston design, according to the sources that I found. And so now that there's more heat to the rings, how can you keep the back of the engine cooler and have a longevity to this engine? Well, and unfortunately this engine only has 250,000 K, so kilometers, so probably 160 miles or 140 miles. But anyways, not very long. This engine should have lasted much longer than that, like its ancestors. But because of that, the flawed design, it's here. So here are three things that simple upgrades you can do. So as you can see, I got all my parts here and all that ready to finish this build. So just the number one thing to do is upgrade your intake. Reason why? Well, I don't know if you can see. Here, I'll bring it to better light. See, that's a very small hole, and you know what? And because of these bends, it causes turbulence and it chokes up the air. And if you remember too how where the intake is installed on the head, on the cylinder head, it's installed generally, I think, roughly by cylinder 2. So all the air has to travel down the head to get to cylinder 5 and 6, and by that time they say that the air stretches, the air is hotter, and it just starves the cylinders in the back. And I noticed this engine in particular, just putting down the road, it would just spew out black smoke. And I'm sure that and those are new injectors in it, and still puked out black smoke. Had a new air filter, still that, and commonly they say it's because of the intake. So I got an S&B, but anything, it doesn't have to be S&B, but anything with a bigger hole, and you see a much bigger hole. The other intake upgrade, this is optional but really recommended, especially if you're running more horsepower, is this plenum from Glacier Diesel. It's a nice plenum because if you look at the comparison, this is nice and flat. There's, it's just a nice flat plate. Well, this one, what they did is they raised it up, and now they say there's able to hold more volume in the intake, and it allows to give more air to the back cylinders and less starvation. So, and they say just this alone, I got a couple people said I've noticed a 100-degree Fahrenheit EGTs less. So really improvement. And that's, again, we're trying to achieve to make the engine run cooler, and if it has more air going into it, it's going to run more efficient and much cooler towards the back of the cylinders. So that is one upgrade. Next upgrade is the exhaust manifold. Here I got a BD exhaust manifold. This, again, this having a bigger improvement compared to the stock over here. Here's my stock manifold. See, it's a little less beefier than this one, a little more open. So again, this will reduce your EGTs. Again, if you can reduce your EGTs, your engine's just going to run cooler. And another theory out there, I don't quite understand this, is that, you know, if you see back here how it's a nice flow design to this port right here. These 4, 5, and 6, they just really flow to each other very good. Well, I guess this one you see here, there's 6 that flows there, and it's connected to these 2 ports, 4 and 5. And see how they're in union? Well, I guess, I don't know, something to do with a lot of idling, I guess, because of the flawed design on these things. If you're doing a lot of idling, I guess what they say is that if an exhaust valve is trying to open and blow out, if another one soon opens afterwards, it actually pushes exhaust gases back into the piston and allows it to heat up more and more and more, and it could lead to ring failure. And that's where my machine shop told me about that. So anyways, that's one common thing we tend to see. So anyways, that's an excellent idea. And you know, doing these upgrades again will not only lower your EGTs, better power, and also will actually, they say even you'll gain in miles per gallon. So and the third additional thing that you can do before you get to this position is, where is the other thing that I'm looking for? Oh, yes. Oh, and also with the plenum, you can get a grid delete. This is an optional thing. You could still keep your original grid heater, but if you keep your grid heater, then they give you these studs to make it slightly longer. But anyways, it's just something optional. And the other option is a coolant bypass. As you can see here, actually, what it does is that it gives you an additional thermostat you could put on the rear of the block, because the theory is, again, because of the flow pattern of the coolant, you know, it has to go from the front towards the back, and by the time it gets to the back, it has to flow back to the front, and it just heats up. So so where you put this thermostat is on the rear of this block right there, and you pull that plug out and slam it there, and you plumb it back to your thermostat with this kit. So very excellent idea. And this thermostat that I'll be putting here, it's 180 Fahrenheit, whereas the stock is 190. So this one will open up sooner and keep flowing the coolant out of here and keep this back of this block cooler, and near the rings, you'll keep those rings cooler. So a very simple upgrade, probably very hard to install if the engine is is in the truck, but another option to look online, you could put a plug, I guess some guys can put a stand-up pipe here with a little pressure valve. If certain pressure achieves, well, then it'll open up, and then they tie it to the thermostat housing right here. And that's an easy option to do, but maybe a little less reliable. I don't know, personally I prefer the fleece kit that they've designed. So those are 3 things you can definitely do and recommended for your truck. And of course, another problem is that injectors tend to inject more fuel if they're worn out and all that. These are new. These are Reman injectors here. I'll go in more detail on the next video, but anyways, that's something really recommended to do. So hopefully this video has helped you to avoid to be in this position and keep running that truck for longevity. So anyways, hopefully this video was very helpful, and I'll make the next video on about, if you're in this position, what else can you do to avoid this situation and really create an engine that can surpass 500,000 miles. So that's what we're trying to achieve here, and I'm giving and is there simple things you can do to make your truck, your stock engine, to get that longevity. And if you're increasing power, definitely will it'll definitely help on the long run also. And actually, I think the reason why this failed is personally because we did run a Smarty chip without any major improvements, so probably that's why it's here. And I remember the EGTs did climb quite high on this engine very fast, and you know, again, it's just because nothing is upgraded in the intake, exhausts. Even actually, another good idea is this is a cold air intake from S&B. I've done the research; they seem to be really good. I got a paper disposable filter and also a reusable filter where you have to oil it. But for the disposable, it's great for dusty conditions. So probably something to think about. But I guess you can build your own cold air intake with a stock air box on the truck. But there's some videos and some people have done that just by going to Home Depot and purchase a few things. So those, with all these upgrades, what we just mentioned, definitely will help and avoid this situation. So anyways, hopefully this video is helpful, and I'll show the next video with additional upgrades with the engine all apart.